So what is this IC? Integrated circuit means what? Okay, I will give you an example, right? So what we have seen till now, एक कौन सा
Diode.
सर्किट देखा आपने? आपने कौन सा सर्किट देखा है अभी तक? बड़ा सर्किट कौन सा देखा है आपने? मे बी एम्पलीफायर का देखा है, राइट?
Yes, sir.
Yes,
Transistor
sir.
as an amplifier. Okay. Now, now in transistor as an amplifier, there was many components. Okay, like चार पांच resistors थे, तीन चार capacitors थे, transistor खुद था, right? So इतने सारे components थे, तो अगर इसका circuit बनाएंगे तो फिर इसका circuit जो है, that will be bigger in size, right? So every time if I want to make an amplifier, बराबर है, नहीं तो फिर दूसरा सर्किट ले लीजिए, आपका जिनर डायोड एज अ वोल्टेज रेगुलेटर का सर्किट है, राइट? सो एवरी टाइम अगर मुझे वोल्टेज रेगुलेटर इफ आई वांट टू प्रिपेयर, then I need some series resistor, load resistor, and maybe Zener diode which is in parallel. तो हर बार मैं क्या करूंगा? Every time I will do the circuit. Yes, no? क्योंकि ये तो हर एक जगह पर सर्किट लगने वाला है, राइट? वी वांट सर्किट एट ईच एंड एवरी प्लेस. ओके, लाइक आपके सेल फोन चार्जर में सर्किट लगेगा, मोबाइल के चार्जर में सर्किट लगेगा. सो हर बार हम सर्किट बनाएंगे क्या? हर बार we will take the components and then we will join. So there is other option, right? So what is that other option? That let us make a IC, integrated circuit, or we can say that it is very 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 compact circuit, right? And then that compact circuit जो है, right? So that is packed in a black color box. We will call it as IC. और जो कुछ connections है, okay, वो हम सिर्फ connections provide करेंगे बाहर में, राइट? फॉर एग्जाम्पल आपका वोल्टेज रेगुलेटर है, कितने कनेक्शंस होंगे उसको? दो इनपुट के लिए, दो आउटपुट के लिए, राइट? सो दैट्स व्हाई व्हाट वी विल डू, यू नो, वी विल ओनली वी विल ओनली फॉर्म द आईसी ऑफ दैट. समझ में आया?
Yes, sir.
Yes,
Yes,
sir.
sir.
तो इसका मतलब ये है कि लेट अस से आई विल ड्रॉ अ डायग्राम फॉर यू. ओके, सो लेट अस से दैट दिस इज आईसी. लेट अस से 74XX सीरीज, 7408 सीरीज, राइट? इसका मतलब ये है कि, और लेट अस से सम 7808 सीरीज, राइट? इसका मतलब ये है कि ये जो आईसी है, ये नंबर है जो कि रिप्रेजेंट करता है, दिस इज अ वोल्टेज रेगुलेटर आईसी एंड इट विल हैव मे बी 4 पिन. दिस इज योर इनपुट पिन, this is your output pin, and let us say this pin is connected to ground. Okay, सो इंस्टेड, और ये आईसी में क्या होगा? ये आईसी में होगा सर्किट, किस चीज का सर्किट होगा? तो ये वोल्टेज रेगुलेटर आईसी है, तो यहाँ पर एक रेजिस्टर होगा, एंड देयर विल बी सम जीनर डायोड which is connected in parallel, right? And in reverse bias. समझ में आया? सो
Yes, sir.
सो व्हाट विल हैपन, यू नो, कि ये जो कनेक्शंस है, राइट, ये ऑलरेडी डन है इन आईसी, राइट? एज वेल एज, देखिए, इफ आई एम टेकिंग द कंपोनेंट्स एंड इफ आई कैन फिक्स इट इन द एरिया ऑफ लेट अस से 2 सेंटीमीटर क्रॉस 2 सेंटीमीटर, राइट? एंड लाइक फिजिकली अगर मैं यहाँ पर कंपोनेंट कनेक्ट करता हूँ, तो मुझे जगह कितना लग रहा है? 2 सेंटीमीटर क्रॉस 2 सेंटीमीटर, राइट? और इसको अगर हमें कॉम्पैक्ट करना है, तो आईसी का जगह कितना आएगा पता है? Maybe it will be 0.2 centimeter into 0.2 centimeter, right? What we are doing, we are just compressing the circuit and fitting it in a very small IC, and that compressed circuit, right, that is also called as integrated circuit. Getting?
Yes, sir. Yes, sir.
Yes, sir.
That's
So
right.
this was the base, right? So the technology where we are scaling the components, right, or we are making the components very 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 small. Okay, so that technology is called as VLSI, right? So what is VLSI? Very large scale integration. Okay, very large scale integration means what? We are like, this was a very small circuit, right? There were only 3 components. But अगर आपके सर्किट में 300 components है, right? Maybe 50 resistors, 50 maybe 200 transistors, 50 capacitors, right? और इन सबको आपको इंटीग्रेट करना है और एक ही सर्किट बनाना है, right? So we will use this technology called as very very large scale integration, right? On the large scale, we are integrating the components, and then, right, then we will form some chips, right? So that chips are called as your VLSI chips, right? That are also called as, in layman language, we can call it as IC, integrated circuits, right? So you know, आपका जो पीसी है, ओके, तो उसका जो मदरबोर्ड रहता है, नहीं तो आप उसका जो सीपीयू रहता है, ओके, आप उसको बोलते हो प्रोसेसर, राइट? यू जस्ट ओपन योर सीपीयू, उसके अंदर आपको एक ग्रीन कलर का बोर्ड दिखेगा, राइट? कभी देखा है आपने?
Yes,
तो
sir.
Yes, sir.
Yes,
पीसीबी
sir.
क्या बोलेंगे वो बोर्ड को? पीसीबी क्या बोलेंगे? Printed
PCB.
circuit board, right? So on that board there will be several ICs which are mounted, और उसके अंदर एक प्रोसेसर भी रहेगा जिसको हम बोलते हैं, मतलब आप प्रोसेसर लेते हो ना, राइट? सो मे बी द प्रोसेसर साइज इज 5 सेंटीमीटर क्रॉस 5 सेंटीमीटर, राइट? तो कोई लोग इंटेल का प्रोसेसर यूज करते हैं, कोई लोग एएमडी, राइट? राइजन अभी चल रहा है, राइट? सो ऑन दैट 5x5 प्रोसेसर, 5 सेंटीमीटर क्रॉस 5 सेंटीमीटर जो आपका प्रोसेसर है, इतना छोटा प्रोसेसर, राइट? उसके ऊपर कितने ट्रांजिस्टर्स माउंट होते हैं? So it is more than 120 millions of transistors, right? So this much heavily we are integrating the circuits, right? So so I have told you somewhat bigger example, right? But 120 million transistors we can also mount in the die area of 1 centimeter square, right? So in 1 centimeter square area also this is possible, okay? So Moore was one scientist, right? So what happened, transistor got invented. तो पिछले टॉपिक में मैंने आपको एक फोटो बताया था ट्रांजिस्टर का, याद है आपको? So maybe वो it was very big photo, right? Because it was mounted. याद है आपको पिछले इसमें एक फोटो बताया था फिजिकली ट्रांजिस्टर का,
Yes, sir.
उसमें उसमें
Yes.
वगैरह लगे थे, राइट? सो वो जो ट्रांजिस्टर था उसका साइज जो था वो 14 इंच लैपटॉप इतना था, राइट? और अभी क्या हुआ पता है क्या? नाउ व्हाट वी आर डूइंग, वी आर जस्ट compressing the circuits, right? So nowadays you can take the example, right? Initially जो आपका सीपीयू का साइज था, ओके, वो कितना बड़ा था? यस, सबसे पहले जो सीपीयू था पीसी, उसका साइज कितना बड़ा था? डू यू नो?
So एक रूम के
As big
बराबर.
as a
एक रूम
room.
के
About one room.
and then there were ACs which were maintaining the temperature, बराबर है? सो ये सुना होगा आपने, राइट? उसके बाद में आपको जब से समझता है, उसके बाद में सीपीयू का साइज कितना था? मे बी यू कैन माउंट इट ऑन अ टेबल, ओके? after that laptops came, after that you are having a cell phone. Nowadays you are having cell phone. What is the RAM of the cell phone? Can anyone tell me of a good cell phone?
8 GB,
8
12 GB.
8
8 GB, right? And what is RAM of your laptop normally?
16,
16 or
4 GB.
8 GB, right? Correct. So can I say your cell phone is a computer now?
Almost.
Yeah.
Yes,
Almost,
sir.
right? Almost every function it is doing. So what I can say, that as what is development in electronics, that size will decrease. What is development in electronics? Can I do you agree with me? Size आपका कम कम होते जा रहा है, and
Function will increase.
फंक्शन
Function
इंक्रीज हो
increase.
रहे हैं, राइट? सो फंक्शन इंक्रीज होने के लिए आपको क्या करना पड़ेगा? कंपोनेंट्स इंक्रीज करने पड़ेंगे, विच इज द मतलब विच इज द वेरी इंपॉर्टेंट कंपोनेंट? ट्रांजिस्टर, राइट?
Transistor.
हाँ, सो मूर्स जो था ना, उसने ये स्टडी किया कि अरे यार, पहले इतना बड़ा था, उसके बाद में छोटा छोटा हो रहा है सर्किट, राइट? लेकिन फंक्शंस भी बढ़ रहे हैं, राइट? सो ही वाज वन ऑफ द को फाउंडर ऑफ इंटेल कॉर्पोरेशन, राइट? Gordon Morse, right? So he told that the number of transistors on the chip would double every 18 months. बराबर है? ट्रांजिस्टर जो कंपोनेंट्स है, ट्रांजिस्टर मतलब लेट अस सपोज हम एक फिक्स एरिया लेते हैं, तो एवरी 18 मंथ्स द नंबर ऑफ ट्रांजिस्टर्स विल गेट डबल, इतना छोटा होगा आपका सर्किट, राइट? इतने छोटे छोटे कंपोनेंट्स इन्वेंट हो रहे हैं. डू यू एग्री विद दिस?
Yes.
Yes,
Yes,
sir.
sir. Yes,
सो
sir.
ये
Yes, sir.
ये जो मूर था, राइट, ही जस्ट प्रेडिक्टेड दिस इन 1965, right? And then there was a pace, and then digital revolution came in existence, right? So this is a graph of how many transistors are there, right, on some specific area, right, from 1971 to 2011, right? Now 10 years below का graph है, फिर भी you can correlate, right? So initially there were only 2300 transistor, right? And nowadays in 2011, what was the peak number? Can you do you know this, how much it is,
2
right?
billion.
2.6 billion.
600.
Yeah, yeah. So you just see, how much it is? 26,000 thousands, right? So 26,000 lakh number of transistors, right? Okay, or you can just see in millions. Okay, yes. So these
Yes,
many
sir.
transistors are there. Okay, and then you can say that in Pentium, how many transistors were there? It was more than maybe how much it is? 10.
A million, more than a
Okay.
million.
And as you increase, right, then Pentium 4 came, right? And after that, nowadays, what is there? i6, i7 processors are there. Okay. So as the computational power is increasing, right, the number of transistor count on the specific area is increasing. Okay. So there were some milestones for IC industry in 14. देखिए Nobel Prize मिला, right, in 1947 for inventing the transistor, right? And they are the foundation of this IC industry. And soon the commercial player like Sony introduced the first transistor based radio, right? So why Sony is famous, because it has came up with the application of this transistor. And then Kilby invented integrated circuit ICs, right? Then Moore came, okay, and Noyce and Moore, right? So this two-person founded the Intel corporation, right? So Intel introduced 1K DRAM, right? So DRAM is what? Dynamic random access memory. So that was long back invented in 1970s, right? And then another milestone is that Intel announced the 4-bit microprocessor, right, in 1971. Okay, and like that, your Apple IBM PC came in 1976, 81. Then ARM came in 1991, right? So our mobile phone are having ARM processor, right? And then Samsung came in picture. They have introduced the 1 GB dynamic RAM, right? So they have introduced a bigger RAM till date. Okay, and now there is system inline packages and all that. Okay, so yes, this was the milestones in IC industry. आपको ये पता रहना चाहिए, being an electronics engineer, or if you are an engineer, at least you should understand that how the development of electronics is there. Okay, so there is one more thing called a system on chip, right? So IC is there, right? So this is your IC. You can see this is the IC of maybe your i3 processor, right? So what is inside that processor? So inside that processor, there are several sub integrated circuits, you can say, or sub circuits. Okay, so maybe you can say that inside the CPU, right, this is like a CPU. So there is a memory, right? There is maybe video decoder, there is some GPU cores, right? Some dedicated processors, and maybe some graphic cards also. And then there is some uh, internet connection IC, right? And then we are interfacing various outside peripherals, right? For example, if you want to attach speaker, mic, right, or any other devices, right? So who will handle that? So peripheral interfaces is a circuit which will be handling all the external connections to the PC, right? Now, what is system in package, right? So system in package, or you can say system in a package, right? So it is nothing but you can get a dedicated IC for dedicated system, right? For example, in your cell phone, right? If आपका अगर sometimes you are not getting any range, okay, and you check that for your service provider, your friend is getting range, so you go to the shopkeeper and tell that okay मेरे फोन को range नहीं आ रहा है. So what he will say कि आपका जो network IC है वो खराब हो गया, right? So that is meant by that network IC will handle all the communication in your cell phone. मतलब उसमें क्या रहेगा? ट्रांस रिसीवर, राइट? उसमें रहेगा maybe for transmission purpose, right, there is a transmitter. For reception purpose, there is a receiver, right? So what is that transmitter and receiver? So we will be seeing in unit number 4, right, that deals with your communication engineering. Okay, so system in a package means what? एक छोटा सा system, उसका एक IC बना लिया, right, and we call it as system in package, right? So you can also classify the circuit based on different criteria. For example, you can say that okay, if let's say you can classify the circuit depending on whether it is series connected or whether it is parallel connected, right? So जैसे voltage regulator का IC है वो हमेशा okay, आपको filter पता है, right? कैपेसिटर फिल्टर सुना है आपने?
Yes.
Yes, sir.
Yes, sir.
हाँ, तो कैपेसिटर फिल्टर मतलब आपका रेक्टिफायर विद फिल्टर कैसे होता है?
Capacitor parallel.
कैपेसिटर फिल्टर कहाँ पर लगाते हैं?
Parallel to
Parallel
the
to the
load resistor.
हाँ, तो उसको फिर क्या बोलेंगे हम? पैरेलल सर्किट, सिंपल. सो डिपेंडिंग ऑन द कनेक्शन वी कैन क्लासिफाई द सर्किट्स एज सीरीज सर्किट और पैरेलल सर्किट, राइट? बेस्ड ऑन द साइज एंड मैन्युफैक्चरिंग प्रोसेस वी कैन क्लासिफाई इट एज इंटीग्रेटेड सर्किट और डिस्क्रीट सर्किट. इंटीग्रेटेड मतलब एक आईसी के फॉर्म में आएगा, डिस्क्रीट मतलब क्या? उसमें कंपोनेंट्स माउंट रहेंगे, राइट? बराबर है?
Yes, sir.
ओके, बेस्ड ऑन द सिग्नल यूज्ड, राइट? कि अपना आपका एनालॉग सिग्नल यूज हो रहा है या डिजिटल सिग्नल यूज हो रहा है? यस.
Yes, sir.
Yes, sir.
Yes,
ओके
sir.
ओके. तो डिस्क्रीट सर्किट कुछ इस तरीके से दिखता है, बराबर है? आपने देख रहे हो? कैन यू सी दिस डिस्क्रीट सर्किट? देर आर सम ICs which are mounted. there is diode, ब्लैक कलर वाला डायोड है, ये ब्लैक कलर 3 टर्मिनल्स वाला ट्रांजिस्टर है, राइट? एंड these are some connecting wires. yes, no?
Yes, sir.
सो डिस्क्रीट सर्किट मतलब
Yes,
क्या?
sir.
हमने जो आपके प्रैक्टिकल में थिंकर कैड सॉफ्टवेयर पे जो सर्किट बनाए, सो दैट आर ऑल डिस्क्रीट सर्किट्स. ओके, सो व्हाट इज द मेन एडवांटेज ऑफ डिस्क्रीट सर्किट? अगर एक भी कंपोनेंट खराब होता है, सो वी कैन इजीली replace the component with another component, right? Maybe resistor यहाँ का खराब हो गया, so what is the cost of this resistor? Any idea?
100 rupees.
हाँ,
Five
रजिस्टर.
hundred.
हाँ, रजिस्टर आता है मे बी 50 पैसे का आता है, राइट? समटाइम्स इट विल कम ऑफ 25 पैसे ऑल्सो, राइट? मे बी 1 रुपी हार्डली. ओके, सो इफ दिस सर्किट में से एक कंपोनेंट खराब हो गया, सो विद इन 1 रुपी, राइट, इफ यू डिटेक्ट विच रजिस्टर इज गॉन, राइट, you can just replace the resistor. So that is the disadvantage of this discrete circuit, right? But what are the disadvantages? That wiring and assembling is very much difficult, right? To take out the resistor and to put it another resistor back at those on the same place, right? So it needs some skilled labor. Okay, so that is one of the disadvantage. Okay, second disadvantage is that if I am replacing the resistor near the IC, then I need to use the solder gun. So whenever I am using the solder gun, what will happen? The circuit will get heated up, and if there is IC which cannot withstand the temperature, तो फिर क्या होगा? वो IC damage हो जाएगा, right? So that is one more another disadvantage of discrete circuit. Okay, also its space is bigger, right? And also this is a time consuming process, right? If you want to scale the device, right, let us suppose आपको अगर power supply का circuit बनाना है, right, and if you want to make lakhs of circuits, okay, so you may need many manpower and all that, right? So instead of this and discrete circuit, we came up with integrated circuit, right? So integrated circuit, there are huge you can say laboratories, or you can say machineries which will create the circuit itself, right, on a chip. Okay, so these are the integrated circuits. Okay, so you can say what is the level of integration? So it is a microscopic electronic circuit, right, which is formed by fabrication of various electronic components, right, by robots. Okay, so means microscopic level circuit, we cannot, human cannot, we can say uh, create, right? So for that we are doing some programming, and with the help of the machines we are just fabricating the circuits. Okay, now you can say that the components like resistor, capacitor, transistor, right, so they are placed on the semiconductor material, or we can call it as wafer, right? So the thing is that while manufacturing the semiconductor only, we are just manufacturing on that, we are just drawing the design, right, or we are engraving the design, so that your transistors, capacitors and resistor will by default be on the chip. Okay, so it can be performed similar operation to large discrete electronic circuits, right? So these are your integrated circuits. Now some more thing about integrated circuit. What are the advantages? It's very small inside. The speed of communication, or the speed of transfer of signals from one place to another place, is very 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 fast. Okay, and also the power consumption is very low. So that's why this IC become very famous nowadays. Okay. Now different types of ICs are there, like analog IC, digital IC, right? So analog IC will deal with which signals? Analog signals. Digital IC will deal with which signals? Digital signals. And mixed ICs means what? Which will deal with both the signals, that are called as your mixed IC. Okay. So uh, so this is your IC fabrication. Okay. So I will show you a video on YouTube that how these ICs are getting fabricated. So basically what we are doing, there is a silicon wafer, and on that silicon wafer we are just dividing the silicon wafer into number of small squares, right? And that one square we call it as one chip. And on that chip, right, on that chip we are just engraving, or we are just having the circuit of any you may say that on this chip there is a circuit of transistor as an amplifier, right? And then we are just putting it on the IC, we are packing it in the black color box, and only the input output connections are given at the end. Okay. And then this circuit is enclosed, and we call this enclosed package as IC package, right? So these ICs we can enclose in various formats, right? For example, if we are enclosing the circuit in a structure like metal can, right? So you can see on the right hand side, so we call it as metal can package, right? अगर हम यहाँ पर अगर ऐसे बॉक्स टाइप में पैकेजिंग करते हैं और उसके पिंस जो है वो फ्लैट देते हैं, तो डिपेंडिंग ऑन द फिजिकल स्ट्रक्चर वी जस्ट से इट एज फ्लैट पैकेज आईसी, राइट? सिमिलरली आप अगर बॉक्स को आईसी माउंट करने के लिए ब्रेडबोर्ड में अगर फंसाना है आपको आईसी को, राइट, देन यू नीड सम पिन्स लाइक दिस विच आर इन टू लाइन्स, राइट? सो इट इज कॉल्ड एज योर ड्यूअल इनलाइन पैकेज. ओके. Now, depending on integration also, we can just classify the IC. जैसे small scale integration वाले IC है, उसमें कितने components रहेंगे? Maybe less than 10 components. Okay, example, आपके जो gates के IC है, AND gate or gate, right? So that comes in small scale integration. Medium scale integration में, when there are less than 100 components, we call it as medium scale integration. Okay. लार्ज स्केल इंटीग्रेशन में अगर 100 से ज्यादा कंपोनेंट्स है तो हम उसको बोलेंगे लार्ज स्केल इंटीग्रेशन. और अगर आपके आईसी पे एक 1000 से ऊपर कंपोनेंट्स है, राइट, then we call it as VLSI, very large scale integration. And the famous example of very large scale integration is your microprocessor IC, right? So depending on how many components are there on the IC, we can classify it into four types: small, medium, large, and very large, right? So any difficulty in this?
No, sir.
No, sir.
No, sir.
So let me, I'll just stop sharing. Okay, so I will share my screen. Can you see my screen?
No, sir.
Yes,
Yes,
sir.
sir.
Yes,
Yes,
sir.
sir.
Okay,
Yes,
okay.
sir.
किसी का
crust,
कंप्यूटर ऑडियो आ
but
रहा
is
है?
only ever found as a
Yes, sir.
Yes, sir.
Okay, so
Yes, sir.
watch to
Yes,
this
sir.
video, right? So they are just saying that how these chips are manufactured. Okay.
Yes, sir.
Okay, sir.
All chips start out with a very simple raw material, sand. Sand is primarily made up of silicon dioxide or silica. Silicon is the second most abundant element in the Earth's crust, but is only ever found as a compound with oxygen. Complex chemical and physical processes are required to ensure that silicon crystals meet the high production standards that apply to chips. To convert silica sand to silicon, the sand is combined with carbon and heated to an extremely high temperature to remove the oxygen. A number of other steps are required to create the finished product, namely an extremely pure monocrystalline silicon ingot called a boule with only one impurity atom for every 10 million silicon atoms. Silicon boules are fabricated in a range of different diameters. The most common sizes are 150, 200, and 300 millimeters. Wafers with large diameters offer more space for chips. Extremely thin.
So this wafers means what? Your semiconductors, right? So it is made up of silicon. So that's why we call always that I'm using silicon diode, right? Silicon or germanium, right? So in that we are preferring silicon, right? So first of all, what we need to do, if we want to form a transistor, we need a semiconductor, right? So here you can just see that they are manufacturing a semiconductor, and on that semiconductor they will just manufacture the circuits.
Thin wafers are then cut from the silicon boules using a special sawing technique. These wafers are the basic building blocks for subsequent chip production. Silicon is a semiconductor. This means it can conduct electricity and also act as an insulator. Its atomic structure looks like this. Every silicon atom has 4 outer electrons. There are no free charge carriers. As a result, the pure monocrystalline silicon is non-conductive at room temperature. To allow it to become conductive, small quantities of specific atoms are added as impurities to the wafer. These impurity atoms must have a number of outer electrons that is either one more or one less than that of silicon. Silicon is in the 14th group of the periodic table of elements. This means that elements in the 13th or 15th group have to be used in this process, referred to as doping. Boron and phosphorus atoms are the most suitable elements in these properties. Lattice, the 5th phosphorus and boron lattice particle.
This is just
exists.
forming of a p-type and n-type semiconductor, right?
Transistors are the smallest control units in microchips. Their job is to control electric voltages and currents, and they are by far the most important components of electronic circuits. Every transistor on a chip contains P and N conductive layers made of silicon crystals. They also have an additional layer of silicon oxide, which acts as an insulator. A layer of electrically conductive polysilicon is applied on top of this. Every transistor has 3 terminals. The middle one is attached to the gate, which is the electrically conductive polysilicon. If an electrical charge is applied to only the 2 outer terminals, electricity cannot flow as the transistor is blocked. This changes, however, if an additional charge is applied to the middle terminal. Electrons from the P layer are then pulled toward the middle terminal and accumulate at the area bordering the silicon crystal and the insulating gate oxide. A channel then forms underneath the gate between the islands of N-conductive material. Electrons can now flow through this channel. The electrical circuit is closed. In this way, the transistor can be switched back and forth between current enable and disable, between 0 and 1, on and off. But how are these layers created on a wafer? The process to manufacture chips from a wafer starts with the layout and design phase. Highly complex chips are made up of billions of integrated and connected transistors, enabling sophisticated circuits such as microcontrollers and crypto chips to be built on a semiconductor surface measuring just a few square millimeters in size. The sheer number of components calls for an in-depth design process. This entails defining the chip's functions, simulating its technical and physical properties, testing its functionality, and working out the individual transistor connections. Special design tools are used to draw up the plans for integrated circuits and develop a three-dimensional architecture of sandwiched layers. This blueprint is transferred to photomasks. Providing geometric images of the circuits, the photomasks are used as image templates during the subsequent chip fabrication process. To ensure that the microscopic structures of a chip are reproduced flawlessly, they have to be fabricated in a dust-free environment with stable temperature and humidity levels. In other words, they have to be made in a clean room. A clean room is a room in which no more than one particle of dust larger than 0.5 micrometers is permitted in around 10 liters of air. This is even cleaner than the air in an operating room. The ventilation, filtration, and supply systems in a clean room therefore have to be extremely sophisticated. Several million cubic meters of air are circulated every hour, and hundreds of air volume regulators maintain a constant air flow. Employees in these production areas have to abide by an extremely strict dress code. They are not permitted to smoke before work or wear any makeup or jewelry. Cleanroom production areas can only be accessed through a special airlock. Depending on their size, several dozen or several thousand chips can be fabricated on one wafer. Operating at approximately a photoresist material is uniformly distributed on this non-conductive layer using centrifugal force. This coating process creates a light-sensitive layer. The wafer is then exposed to light through the photomask, and special exposure machines known as the chip template, known as reticles, are used to transfer the complex geometric patterns of the circuit design to the silicon wafer of oxide below. The unexposed part remains as is. The exposed layer of oxide is etched off in the areas that have been developed using wet or special gases bond with the substrate to be removed in the reaction chamber. This enables microscopic layers to be removed and the thin oxide layer are etched off. These two layers only remain intact in the center is applied. The wafer undergoes another cycle of applying photoresist, exposure through the mask, and stripping. Contact holes are etched to provide access to the conductive layers, enabling the contact.
Am I audible?
Yes, sir. Yes, sir.
Yes,
So
sir.
you can just
Yes,
see
sir.
that these are nothing but your transistors, right, which are engraved on the semiconductor base, right? So maybe you can say just consider it as three terminals of the transistor coming out from a base emitter and collector, right? So this is not exactly a transistor, but it is MOSFET, right? Advanced version of transistor. But by seeing this video, you might have got some idea that how this is happening, right? From a single wafer, right? They are just um, doing some process on the wafer, okay, and they are coming out with millions and millions of transistor on a single wafer. This is all happening on the by using some optical technologies, right? As you have seen, okay. So they are just showing some samples
And
here.
Interconnections to be integrated in the wafer. Says may be repeated multiplicated in this space between the device, which can be mounted on circuit boards using different types
So
of
these are all
terminals.
different ICs, right?
Electronics with
So you
tiny
can
building
just
blocks that have such a big impact, easier, safer, and greener.
so I will just share this link also. Attendance link is also shared. So just see the video when you will get time. Okay. So anyway, any problem in this?
No, sir.
Okay. So
Sir.
basically,
Sir.
this was just an introduction regarding this ICs, right? What important is that we need to learn two types of ICs, right? One is your digital ICs and second are your analog ICs, right? So your unit number 3, a small part has been covered today. We will be starting with your analog ICs, that is operational amplifier. क्या नाम बोला मैंने? Operational amplifiers, right? In the next lecture. Okay. So till that time you can just give the attendance. Okay, yeah.
Sir, is there any reason for making it round? I mean, they could have made it square
Yeah, we could have made it square, but
because it
maybe
would be effective more.
yes,
Because
yes, but maybe if what I think maybe scientists can give the answer, but a logical answer to this is that we have seen the process where we are just making the layers, right? So if we want to make the layers, right, then maybe round chips are better to distribute evenly the material, right? Means spin करेंगे and then it will get distributed, right?
yes, sir, got it.
Yeah. So maybe that is one of the reason what
Yes,
I think.
thank you.
Okay, any other difficulty?